welcome. In this video, we'll discuss Congruence Standard 2 from the Common Core Standards for Geometry. This video will focus on describing transformations as functions that take points in the plane as inputs and produce other points in the plane as outputs. Let's take a look at this rule for a transformation. We're going to translate each point in the plane 5 units down and 3 units to the right. We'll see what effect this transformation has on triangle ABC, and then we'll try to generalize that effect to write a function rule. Let's get started. So we'll start with point A. We'll translate 5 down and 3 to the right. 5 down, 1, 2, 3, 4, 5, and 3 to the right, 1, 2, 3. And that produces the image A prime. Let's stop and record the coordinates of the input A, which is 3, 7. Let me clean that up for you. And let's record the coordinates of the output A prime, 6, 2. Oops. And let's continue this little investigation by finding the output for point B. B goes 5 down and 3 to the right. 1, 2, 3, 4, 5. 1, 2, 3. There's the image B prime, and we'll write down the coordinates of the input and the output. B is 7 over and 9 up. B is at 7, 9. B prime is 10 units over and 4 units up. 10, 4. Having a lot of fun. We're going to continue that fun with transformation around point C. 5 down, 3 to the right. 1, 2, 3, 4, 5. 1, 2, 3. Labeling C and C prime and looking for coordinates. C is 8 over and 5 up. 8 over 5 up. C prime is 11 units over and 0 units up. 11, 0. Fantastic. Let's complete our drawing by joining points A prime and B prime, B prime and C prime, A prime and C prime to form triangle A prime, B prime, C prime. And let's notice that triangle ABC looks an awful lot like triangle A prime, B prime, C prime. It's just that each point has been translated down and over to the right. Fantastic. Now, one of our goals again from Standard 2 is to focus on describing transformations as functions. So let's see if we can come up with a function rule for any random point P in the plane with coordinates x, y, and try to describe the coordinates of the image P prime once and for all. So in particular, we'll look for a rule that transforms the x coordinate into something else and a rule that transforms the y coordinate into something else. We can use the data we collected from this triangle to help us generalize with a function rule. Here goes. Looking at the x coordinates, we need to transform 3 into 6. We need to transform 7 into 10. And we need to transform 8 into 11. So we have to look for structure here. We need to find some math process that takes all these 3 inputs and produces these 3 outputs. Well, that's not so hard. Plus 3 looks like it will do the job. 3 plus 3 gives 6, 7 plus 3 gives 10, 8 plus 3 gives 11. So in general, we'll take x to start with, and we'll end up with x plus 3. Great, I believe we've described the x component of our rule, and it remains to describe the y component. So let's study the y's. 7 goes to 2. 9 goes to 4. And 5 goes to 0. Again, we're looking for structure. We're looking for something that takes these three inputs and produces these three outputs. And after a little bit of thought, we can come up with this rule. Minus 5. 7 minus 5 is 2. 9 minus 5 is 4. 5 minus 5 is 0. In general, y goes to y minus 5. And that's the function rule for this transformation. Making a little bit of room to write down that rule in sort of a standard way. We can say start with the point x, y, and transform, this little arrow means transform, to the point whose coordinates are x plus 3 and y minus 5. And this right here is the function rule that explains what this transformation does to points in the plane. Hope that helps you with your understanding of Standard 2. Thanks for watching.